So this is going to be the second video I make on this, and the reason why is because the first video I made on this, which is actually quite good, uses a different method, and this method is slightly different from the one that I illustrated before. I just want to review something very quickly. In the past, we had added fractions, and so what we did was we took a look at this, and I'd say, all right, the common denominator is going to be x times x plus 2. And so I'm going to multiply both these um, fractions to make sure I get a common denominator. And then what I'd have is 3x plus 4x plus 8 all over x times x plus 2, which is 7x plus 8 over x times x plus 2. Now, we're going to do something very, very similar, but it's going to be slightly different. We're going to simplify a complex rational expression. And I'm going to use this as our example. I'm going to say, what if we had 3 over x plus 2 over 4 over x? Now, I just want to point out one other thing before I begin. If I had, well, let's not use that. If I had 1/2, we all recognize that 1/2 is really 1 divided by 2. So if I had a over b over c over d, what I really have is a over b divided by c over d. And I'm not going to go too far into this right now. But what I am going to say is this. I know that my lowest common denominator is x times x plus 2. Now, because I'm trying to simplify this, I'm not trying to solve it, I'm trying to simplify it. What I'm going to do is this. I'm going to multiply my top fraction by x times x plus 2. Now I'm going to multiply my bottom fraction by x times x plus 2. All right? Let me make this so you can actually read it. Sorry. X times x plus 2. And you'll notice I said find the least common denominator of every fraction, and so that's what I did. But I'm going to multiply each fraction by the least common denominator. And the reason why is because this. I don't want a complex fraction. A complex fraction looks something like this, where I have a fraction here over a fraction here, right? But the nice thing is this. How many times does x plus 2 go into x times x plus 2? Well, the x plus 2 and the x plus 2 simplify to 1, and I'm left with just 3x. Technically, it's 3x over 1, but I'm just going to write 3x. And here, my x cancels with that, and then I distribute 4 times x and 4 times 2. I get 4x plus 8. And that's it. That's all you have to do. I'm going to do another example, and I'm going to actually just use numbers in this example. And once again, as always, if I'm going too quickly, it is a video, so by all means, please stop and just watch it again. So if I had something like this, and once again, I'm going to use 2/3 plus 3/5. I'm going to show you how this is different than just adding fractions. If I was just going to add fractions, I'd recognize that my common denominator was 15. Now I'd multiply this by 5 over 5, and this by 3 over 3. And I'd get 10 over 10 plus 9 over 15, and I'd get 15 over 19. I'm sorry, that's not true. I'd get 19. Oh, goodness me. I would get 19 over 15. But we are not doing that in this case. So if I had, and here's where it's different, I'm not trying to add them. I'm trying to simplify them. And so what I'm going to do is, I recognize that my lowest common denominator is 15. So I'm going to multiply by 15 simply because I'm multiplying by 15 over 15, simply because when I do that, I know that I'm going to lose my denominators. Take a look at this. 3 goes into 15 5 times, and I get 5 times 2, which is 10. 5 goes into 15 3 times, and I get 3 times 3, which is 9. And now you might be saying, well, 19 over 15 is not the same as 10 over 9. And that's true, because this was when I was adding these two fractions, and this was essentially when I was dividing those two fractions. So there's a difference. This is addition, and this was division. All right, so now I'm going to do one more. I'm going to do one more example, and hopefully it will help. And I'm not going to do the addition portion again because I'm afraid it might end up confusing people. Let's look at an example like this. B squared over b squared minus 16 minus b over b plus 4 over b over b squared minus 16 minus 1 over b minus 4. So if I take a look at my four denominators, right? I'm going to take a look at my four denominators. I have a b squared minus 16. I have a b plus 4. I have a b minus 4. And I have another b squared minus 16. Well, b squared minus 16 is really b plus 4 times b minus 4, which means here I have a b plus 4, and here I have a b minus 4, which means that in order to have a common denominator, here I would need to multiply by a b minus 4, and here I need to multiply by a b plus 4. But keep in mind, I'm going to multiply each term. There's 4 fractions. I'm going to multiply each of them by the least common denominator, which happens to be b plus 4, b minus 4. And b plus 4 times b minus 4. I didn't really give myself a whole lot of room here. That was silly. And b plus 4, b minus 4. All right. Now take a look at what happens. I'm going to erase this for now. Take a look what happens here. When I do that, my b squared minus 16 will cancel out with this, and I'm left with b squared. B plus 4 will cancel out with b plus 4, and I have, so it's minus, because I have my minus sign, and I have to distribute, and I get b squared minus 4b over, and look what happens down here. I should be using a better color than this. My b squared minus 16 is the same as this, so those go away, and I'm left with b minus, and then I'm going to put in parentheses, my b minus 4 will cancel out with this b minus 4, and I'm left with 1 times b plus 4, which is obviously b plus 4. And now you'll notice all 4 of my denominators have gone away, and that's because I multiplied by the least common denominator. Now I'm going to combine like terms. I have a b squared minus b squared, which is 0, and then I have a negative 4b, which gives me a positive 4b. Then I have b minus b, which is 0, and then I have a negative 4. You have to be careful because of these negative signs. You have to distribute this. Which means I have a negative b. That's it. I hope this video was helpful. Rewatch it again if you need, and stop it and play it on places where it makes sense. If you go into your textbook and it doesn't seem to make sense and you're really struggling, you can watch my other video, but try not to get confused.